Alright, we have section 9.2, and this section is direction fields and Euler's method. Basically, in this section, we're going to cover three main objectives. The first two are going to be covered in this video, and then I'm going to show you guys how to do it using Desmos when we get to class, and do the last part in class as well. Let's start with creating direction fields. So direction fields are also called slope fields, and they're useful for investigating first order differential equations. Okay, they have to be first order. In particular, we consider the first order differential equations of the form y prime is equal to f of x and y. The line segments created indicate the direction in which the solution curve is heading. So the direction field helps visualize the general shape of the curve. At each point in a direction field, a line segment appears whose slope is equal to the slope of the solution to the differential equations passing through that point. Alright, so this is basically what we're going to be doing right now. I'm going to model this. I'm going to do it by hand. Okay, so here we have to create a direction field of the following. So we have y prime is equal to x plus y, and we have the y's of 0 is equal to 1. Okay, so we're going to create a table, and then with the points on each of the points, we're going to have the slope. And what we're going to do here is we're basically going to graph each of those slopes so that way you can have an idea of what's going on. Okay, so I'm going to use some points. So I'm just going to try to start with like easy points, like for example 0, 0, 0, 1, 0, 2, 0, 3, and then I'm going to do 1, 0, 1, negative 1, 1, 1, 1, 2. So basically the idea, if you're going to do it by hand, is to do all the points in your, it's not going to be possible to do every single one, but you want to do points like close to each other so that way you can kind of see the direction of where it's going. Okay, so here, if we plug it in our x and our y values in here, we're going to get our slope. Remember, this is your slope. Alright, so I'm going to do that. If I plug it in 0 for x, 0 for y, my slope is going to be 0. Why? Because 0 plus 0 will give me 0. And I'm going to do the same thing for the other ones. So basically we're adding the coordinates, and that's going to give you your slope. Why? Because that's what is given here. Okay, so 0 plus 1 is 1, 0 plus 2 is 2, and so on. I can move on and do all the other ones. This is an easy one because you're just adding the coordinates. Alright, now the fun part comes when you have to graph this. Okay, so here I'm going to kind of label my x and my y axis. We're not doing that many numbers, but might as well kind of have an idea. Okay, so if I'm going to graph the first slope, which is at 0, 0, that will be at the origin, right, 0, 0, and my slope is 0. So my slope of 0 is a flat line. Now we're doing tiny little lines, okay? We're not doing like a full length line like when you're graphing a linear equation. Now we're just doing a tiny little line. 0, 1, so 0, 1, my slope is 1. So remember, slope is 1 means is 1 up, 1 over, but I'm not gonna like actually go up and 1 over. I'm just gonna kind of sketch the direction of where that's supposed to go. Maybe that's not that accurate. Up 1, 1 over, something like that. At 0, 2, then you have a slope of 2, so notice 2 is bigger than 1, so that means this line is steeper than the previous one. 0, 3, slope is 3, so it's even steeper. And then I'm going to move on to point 1, 0. 1, 0, my slope is 1. So it's parallel to this one. 1, negative 1, my slope is 0. So I have a flat little line. 1, 1, I get a slope of 2. 1, 1, slope of 2. So notice it's parallel to this one. And then we have the last one, 1, 2, the slope is 3. 1, 2, the slope is 3. Okay, so notice if we do this by hand, it's going to take us forever, right? Okay, so we do have a program that would do it for you, and Desmos is one of them. So if you do it on the program, this is what it should look like. Notice it's kind of what I was doing. So you're always going to kind of see, you remember slope of 0? I'm going to highlight it so you guys can see it. You're going to be able to see this. It kind of is like a pattern. It always isn't a diagonal, okay? Now what we're trying to do here is try to like see where your solution is, right? So we're talking about a specific point, and I'm going to use this graph because it would take me forever to do it by hand. So I'm looking for the point 0, 1. So remember this point here is 0, 1. This is x, this is y. So I'm going to look for that on this graph, and I'm going to kind of try to see where my curve is going, okay? Because that's going to be the solution. The solution is going to go through that point. So 0, 1, 0, 1 has a slope of 1. And notice this kind of like tells you the direction of your curve. Ta-da! Alright, so I'll make a note here. Solution of the curve goes through 0, 1. So it has to go through the condition that they give you on the problem, and then you can kind of follow the path or the direction of the little slopes of the slope field. Okay, now on the next page I have a link, and hopefully everybody's able to get to the link. Or you can just go to Google search. So if you go to Desmos, or if you just Google Desmos slope field generator, it will take you, I think it's pretty much the first link. If you're clicking on your PDF of this form, you should be able to click on this and it will take you directly. So this is already like, it's a generator. So you can put in your function and it will generate all the slopes for you. And you can see all the slope field basically. Okay, so this is kind of like a tool to be able to see it and do it faster instead of doing it by hand because it takes forever. Now here, what I want you guys to do is basically practice, and I want you guys to kind of sketch this. So if you use Desmos, you plug in your function here, your differential equation, and I want you guys to see your slope field, okay, and see if you're able to use it. Okay, this is just practice. This is just for fun. Okay. Alright, the last part, I do want to do this part in class, so this is a fun part too. This is the second fun part of the section, so that's why I want to do it together with you guys. So the only thing I want you guys to do today is practice this on Desmos. Alright, if there's any questions, I'll be happy to help you in class. Thank you for watching this video.